Hello and welcome to the computer learning class by Accelerate Computer Systems. My name is Arun and I will be your trainer today. Computers work with different numbering systems, and it is important to know how computers use these numbering systems and be able to calculate value for each of these. This will help you understand and calculate the correct number later when we'll be learning about IP addressing and subnetting. This is an essential skill to be able to convert any numbering system to binary and vice versa. This is important because computers, internally they work with binary. Today we'll be learning about decimal number system, binary number system, and hexadecimal number system. All right, let's start. Before we start learning about the numbers, let's see where these number systems are used inside a computer. Let me start with the decimal number system. The IP addresses, as you can see here, they are written in this format. We are very much familiar with this. Now, this is the number system that we use in our day-to-day life. Another important number system is called the hexadecimal number systems. This is used in MAC addresses, for example, and IPv6. We'll have a look at it later on. Take a note on how hexadecimal numbers are written. These are a combination of numbers and letters. Now comes the binary number system. Now this is used internally by the system. We know that computer, they work with ones and zeros. Whatever information is sent to the computer, it is converted to ones and zeros. We are going to discuss these in the next few slides. We will also practice how to convert hexadecimal and decimal numbers to binary and vice versa. This will be really useful when we are dealing with subnetting. Now let me start by explaining the very basic principle as to how computers calculate value of any given number. That will help you understand the number systems better, which we'll be doing next. In every number system, every number has a place value, and it increases moving from left to right. The factor by which every value place value increases differs from one system to another. If you want to get the total value of given number, then we need to multiply the place value with the number and then add the resulting values in case there are more than one numbers. Let's assume that we have a place value of 1, 2, and 3. And if we get a number which is 768, the system will first place each number at its respective place value. Then it will multiply that respective value and then add the results. In our example, when we multiply 8 by 1, we get 8. You see the place value for 8 is 1. We get 12 for the second one because if you see here, 6, the number is 6 and the place value is 2. And for the third number, we get 21 by multiplying this 3 with 7. Now the system adds these numbers to get 41. In summary, the system first identifies the respective place value of every number, then multiplies the number with the place value, and finally adds the numbers to get the results. Now, with that in mind, let's go and learn about our first number system called decimal number system, something that we use every day. Now, this is called a 10-based system, and we can use 10 numbers from 0 to 9. We know how to write the numbers starting with 0 up to 9. Now, how do you get the next number? We start from 0 and then put 1 to the left of it. Now this way we get 10. Just like the previous one, we keep adding one number to the right of 1 until we reach 19. Now we start from the beginning and use 0 and add 1 to the already existing one and get 2, thus getting a number 20. We already know that to get to a total number, we need to multiply the number with the place value. In decimal number system, the place value starts with 1 and increases by a multiplier of 10. So the first place value is 1, which is the leftmost number. Second one is 10, third is 1000, fourth is 10,000, etc., etc. Let us see if you have a number 7. Now its place value will be 1 because it is just one number. To get the total value, system multiplies this number with its place value, which is 1. This gives us 7. Now if we had 770, which is 70, and then we know that 0 has a place value of 1. If you multiply 1 with 0, you get 0. 7 has a place value of 10. So we need to multiply 7 with 10 to get its value, which is 70. Let us take a bigger number now. 493. 493. This number 3 has a place value of 1. So we will multiply 1 by 3 and get a value of 3. 9 has the place value of 10. If we multiply 10 with 9, you get 90. And 4 has the place value of 100. And if you multiply 100 with 4, you get 400, as you can see here. Now if you add all these together, you get 493. Let's take another example. This time let's take a number 4896, so 4896. First, let us look at the place value of each of these numbers. 6 has a place value of 1, so its value is 1 multiplied by 6, and we get 6. Similarly for 9, we get a value of 90 by multiplying 9 with its place value, which is 10. With the same calculation, we get a value of 100, 800 for 8 because its place value is 100. And we get a value of 4000 for 4 because it has a place value of 1000. Now that we know how decimal numbers work, let's go ahead and learn about binary. Now let us have a look at the binary number system. This system works with only two numbers, 1 and 0. If you remember, decimal number system, it works with numbers from 0 to 9. Here is how the numbers they increase in binary. We start with 0, then and the second number is 1. Now since we have just two numbers, we will again start with 0 and add 1 to the left and get 1 0. We add 1 to it and get 1 1. To get the next number, both numbers will become 0 and we will add 1 to the left of these. And this continues. Now we need to know the place value for binary. System processes 1 byte or 8 bits as basic operable unit. Now let's see how the place value is calculated for 1 byte. It starts with 0 to the power of 2 to the power of 0 and goes up to 2 to the power of 7. When calculated, we get the value 1, 2, 4 up to 128. These are the place value for the 8 bits. Now let's take this number and see how to get this value. Let me take a number of this 11001010. Let us now take each of these numbers and multiply them with their place value. Here, as you can see it here. Now just add the numbers that we obtained and you get the result 202. Now it is important to be able to convert from any number to binary. This will be really helpful when you learn about networking. More so because computers internally, they work with binary and thus always convert any number to binary to be able to process it. All right. We have already seen how a decimal and binary numbering system works. We know that decimal numbering system has numbers from 0 to 9 and the place value starts with 1 and increases by a multiplier of 10. In binary, there are only two numbers, 1 and 0, and the place value starts with 2 to the power of 0 and increases with each number, that is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, etc., which results in a place value of 1248 up to 128 in a byte. In hexadecimal numbering system, we have numbers from 0 to 9 followed by letters from A to F. So effectively there is no 10 or 11. Instead, it has letters that represent numbers in decimal system. So technically it is still 10, 11, 12, 13, 14, 15, etc. But these are written as A, B, C, D, E, F. So in hexadecimal, if you want to say 10, you would say A. If you add these numbers, you will see that there are in total 16 numbers, which also includes 0. Place value of each of these numbers, it starts with 16 to the power of 0. You remember in binary it was 2 to the power of 0 and increases by 1 each time. In hexadecimal it is 16 to the power of 0 and increases by 1 power. So for example, say 16 to the power of 1, 16 to the power of 2, 16 to the power of 3, etc. After calculation, this gives us the place value as 1, 16, 26, 4096, etc. Now, let's take a number. Let's see if we have a number in hexadecimal 8FB. Now, let's find out the place number for each and try converting into decimal number. B has a place value of 16 to the power of 0. So, it is multiplied by 1, which is the place value. As you can see in the table, B has a value of 11 because after 9 we have A, which represents 10, and B, which represents 11. F represents 15 in the table and needs to be multiplied by 16 to get its place value, which is 240. Now, to get one place value of 8, we will need to multiply 8 to 256. This will give us a value of 2048. Now we need to add these numbers to get the value 2299. So 8FB in hexadecimal is equal to 2299 in decimal. To be able to master these numbers, you need to know the base value of each and most importantly, the place value of every number. On the next slide, let's see how we can convert the numbers from decimal to binary and hexadecimal and see the calculation. If you want, you can go online and look up for a converter that converts from one type of number to another. I have a converter here. Let's try and check a few numbers and convert them from decimal to hexadecimal and binary. Let's try to convert number 6 from decimal to hexadecimal and binary. You see that decimal 6 is in hexadecimal 6. It's also 6. Let's check it in binary. It is 110. Do you remember the place value in binary? Let me just put it here. So it's 1, 2, 4, 8, etc. Right? So it's 110. So in this case, if you add these two, because there is 1, you get 6. Okay. Now let's try to convert a number 15 in decimal to hexadecimal and binary. In hexadecimal, it is the letter F. See, and then which has the value of 15. Now in binary, it is 1111, which means 1248 is the place value for these from left to right. Just add these numbers and you will get 15. Now let's try to see 50, number 50, how it looks in hexadecimal binary. In hexadecimal, it is 3, 2. We know that the place value of 2 is 1 and 3, it is 16. Multiply 2 by 1 and 16 by 3, we get 2 and 48. Now add these numbers to get 50. In binary, it is 110010. We'll check the number 450 now. It's IC2 in hexadecimal. And it is 111000010 in binary. Again, what you need to do is you need to be able to know the place value for each of these and convert and multiply them with their place value and add these numbers. Today we learn about the numbering systems that the computer work with. We have learned how decimal, primary and hexadecimal number these systems work and where these are used in the computer. It is important to know these because at a later point of time when we are learning about IP addressing, we'll be converting numbers from one system to another, mostly from others to binary because computers work with binary numbers. I understand that this topic requires a lot of practice. In the next video, we will try to convert a few numbers into binary and from binary to other numbers to give you more practice. I hope you found this video helpful in learning about the numbering system. Do remember this is just an introduction. Do let me know your feedback. It will help me improve the content. If you find the content useful, share it with your friends and family and subscribe to the channel to get notified about the new videos I post. At Accelerate, we work with students and startup companies in Canada by providing them with high performance and low cost computing devices to help them learn and grow. These Dell laptops, they start at just 400. If you would like to know how you can save on your next laptop purchase, do send us an email. Thank you so much for learning with me today. I will see you in the next video.